consists of syntax analyzer phase, or you can also say that this phase is also called as parser. Okay, so it is the second phase of the compiler, and in that phase compiler take tokens as an input and produces parse tree as an output. So we need to discuss completely about syntax analyzer phase, as it is the very important topic, very important topic for the perspective of GATE exam. And around 60 to 70%, as I also said you earlier, is based around 60 to 70% of compiler design for the GATE exam is completely based on syntax analyzer phase or parser. So we will try to cover it into 3 to 4 sessions, because we need to solve all previous year questions, important previous year questions, all concepts, all kind of parsing techniques, and we'll go one by one. Okay, so I am again starting today from the basics of parsing, because you need to know that what parsing actually is. So if I talk about the definition purpose of parsing, then parsing is checking whether given string is a member of given CFG or not. It is called as parsing. Means given string is there in the grammar, whether it is a part of context free grammar or not. If it is a context free of it is the member of context free grammar, then we will say that it is a, if it is a member of that grammar. Suppose a string is there, suppose AA. Suppose this string is a part of grammar like S derives AA, then you can say that it is a parsing. But suppose my grammar is only deriving only A, then I will say that it is not a parsing. We will discuss it in a very detail, right? So don't get confused, just stay patient, because I need to make stepping stone for you so that we can go smoothly after that. Now, what is syntax? Again, an important terminology in the parsing is syntax. Syntax is basically the way in which tokens are arranged together. It is known as syntax. Means there are various kind of tokens which we are going to discuss with the help of previous year questions, and the way in which we are arranging them, it is called as syntax. If you have completed the theory of computation, then I hope you are getting clear with this concept. I hope you are getting clear with. Is TOC completed, guys? Please respond. Is your TOC completed? Have you read TOC for the GATE computer science? Please respond, so that at least I can understand that you have the knowledge of such kind of terminologies or not. Okay, so your TOC is completed, na? Good. Okay. Now parser or syntax analyzer. Okay, so parser or syntax analyzer, you can basically say that second phase is a syntax analyzer, or you can also say that it is a parser, because it generates parse tree. That is why it is called as parser. It is a program that takes tokens and context free grammar as an input and verify token are member of CFG or not, right? So yesterday we have discussed that whether our following statements are having uh, valid statements or not, valid tokens or not. If it is a valid tokens, then they will verify the token and they will verify that whether it is a part of context free grammar or not. If it is a part of context free grammar, then they will say that they will say that they will generate parse tree. But if it is not a part of our context free grammar, then it will generate syntax error. So if tokens are member, it produces parse tree as an output. Otherwise, it produces syntax error. Okay. So for example, on the place of printf, I just write printf or printf, right? I just missed t here. I just missed t here. So in lexical analysis phase, what will happen? In lexical analysis phase, it is considered as a valid token, isn't it? It is considered as a valid token. But in syntax analyzer phase, when this token will pass to the syntax analyzer phase, this printf, it is not a member of context free grammar for the any programming language. Like for C, it is not a part of context free grammar, so it will generate syntax error, that you have syntax error. But it will not generate lexical error, because it is a valid token, but it is invalid if we verify it with the context free grammar of C language. So printf, it is a very, it do not show lexical error, but it will show syntax error. So I hope you are getting clear that when CFG will generate syntax error and when it will not. The next one is CFG are used to define syntax of programming languages. So basically syntax of programming language means context free grammars are basically rules which is used to define any programming language. Depending on the programming language, rules are considered, right? So CFG are used basically to define syntax of any programming language. You can note that because this was asked in the one of CSIT exam. So you can note that point, that which grammar is used to define syntax of programming language. I hope it is ISRO's question, and they gave that context sensitive grammar or recursively enumerable language or grammar or context free grammar. So it is once asked, so you can note that or you can mark that. Now, unambiguous CFG are used to design a parser. Unambiguous CFG जो होगा, okay guys, two guys are asking question, but once I am completed with this basic concepts, I will give you time in the question answer session. You can raise your queries there and I will try to solve that, right? So just hold your queries just of as of now. I will take it in the last 15 to 20 minutes of this hour, and then we will then I will solve all your queries, right? So just hold on. Now the last point is unambiguous CFG are used to design parser. So it is also one of the point which was asked in any CSIT exam. So I have just collected that directly from the question. You just need to make a note of it, that unambiguous CFG are used to design parser. So there is a need that what is unambiguous grammar and what is ambiguous grammar. We will also discuss it as perspective of a compiler design, but if you have completed TOC already, then I hope you are very aware with the ambiguous and unambiguous grammar. But still I will discuss when we will take that there is a need of that, right? Now parser is designed by using deterministic PDA. These are the important points which I am discussing with you, so that you can get this point directly. You can note that, you can take a screenshot of that, or you can note in your notebook, right? Because this kind of points you will generally don't get directly from anywhere. You just need to research previous year question, and then on the topic wise you need to add on that topic, right? So I think you need to make a note of it. It is very important point, that parser is designed by using deterministic PDA, right? So I hope you have jotted down. Next one is, there are two types of parser. The first one is top-down parser and next one is bottom-up parser. So our discussion of syntax analyzer phase will completely revolve around top-down parser and bottom-up parser, right? If I talk about parser, then top-down parser is there and bottom-up parser is there. Now, in top-down parser, we have recursive descent parser, LL1 parsing technique, LR parsing technique. In LR parsing technique, we further have LR0 parsing technique, SLR1 parsing technique, LLR1 parsing technique, CLR1 parsing technique, and operator precedence parser technique. But as of gate syllabus, operator precedence parser were asked, means they didn't ask any question from operator precedence parser since previous 7 to 8 years, but still I will discuss this parsing technique as well. But we need to make our full concentration on LR parsing technique. LR parsing technique is 5-star important topic, right? You can make 5-star for it, because you can at least assume 2 marks directly from LR parsing technique. In this we need to discuss LR0, SLR1, LLR1 and CLR1. It is very important. I am still considering this one as a 2-mark question directly. You can get in 2021 as well, in GATE 2021 as well, right? So make this as a VIP topic for GATE 2021, and we will discuss LR parsing technique first, because it is our priority topic in parsing technique, okay? And then we will discuss operator precedence parser. Then we will come to the top down parser. In that we will discuss recursive descent parser and LL1. Basically recursive descent parser, it is not a topic of GATE as of the current syllabus, but still I will discuss the important concept of recursive descent parser with you, so that at least you can get the knowledge and you can attempt the relative question, the relatable question if they ask. But you need to focus completely on bottom up parser techniques. It is very very important. And you need to also focus on LL1 parsing techniques, right? But recursive descent parser technique and operator precedence parser techniques are very low priority topic as of the GATE syllabus, but still don't worry, I will not left any single topic with you in parsing techniques, right? Now if I go with the bottom up parsing, then let's have introduction of bottom up parsing techniques. Then we will okay, previous slide you need Saksham, this slide or that slide? Saksham is asking for previous slide, right? Which previous slide, this one or that one? Are you okay, Saksham? This is the first slide, this is the second one, third one, and this is fourth one. Okay, this is the first slide of our today's session. Is it okay? Okay. Now we are going with the bottom up parsing technique. We are taking introduction of bottom up parsing technique first, and then I will go with the important parsing technique, how to design parsing table, how to design DFA for that, and what kind of GATE question they may ask from this topic, right? So bottom up parsing, bottom up parser constructs the parse tree starting from the given string and proceeds until the symbol, right? So bottom up parser construct parse tree starting from the given string and proceeds until the ending of the symbol, right? So suppose your string is suppose x x x y z, then your string will started parsing from this x onwards. After that this one will cover and until ending symbol, you can say that until ending symbol. Okay, and it will get parsed like that. Don't worry, we will take an example, very interesting example, so that you can understand, right? Okay, bottom up parser uses rightmost derivation in reverse order while construct the parse tree. So it is very very important topic. It is very very important point. This statement is asked in GATE, ISRO, BARC, okay, and IBPS SO exam directly. This statement is very very important statement and was asked in every UGC net. It is also part of UGC net CS exam after MTech. So this is very very important, and you need to make a note of it, right? So bottom up parser uses rightmost derivation in reverse order. And how bottom up parser uses rightmost derivation, we will also discuss it, and how it parse the tree in reverse order, we will also take an example and discuss it, so that you can understand it practically. But you should have to make this as a priority point in your handbook, in your notebook, so that you can revise it before your exam, before your any CS kind of exam, right? It is very very important point because it was asked in every CS exam. Now if I talk about one more terminology, there is a simple terminology, a definition point of handle, that what is handle, because once in GATE exam they have asked that what how many handles are there in the grammar, in the string of the grammar, when we will go parsing with that. So handle is a part of sentential form that is completely matches with the right hand side part of grammar production. So handle, it is a part of sentential form. Now the important terminology is what is sentential form. So we will also take an example and see that what handle is actually. It is when we generate parse tree na, then when we reduce any symbol, then that reducing symbols are called as sentential forms. I will tell you with the example, right? But as of definition purpose, I am just discussing it so that your theoretical points can't be missed, because I can directly start from example. But if I will directly start from examples and previous year GATE question, you will get confused, sir, you have didn't discuss this point. So I am discussing theoretical points of our today's session, then we will go with the question sessions, right? So just have patience. So because I it is very important to discuss this kind of terminology. Once I will be completed with it, we will go with the previous year questions smoothly. Now the point is, whenever a handle is detected, it is replaced by its left hand side non-terminal. Suppose in a grammar, S derives AA. So when we are detecting AA handle in our parse tree, we will replace it with the left hand side non-terminal. Means if we are getting AA in our parse tree, we will replace it with S and we will generate parse tree like that, right? So I will discuss it with the example, but I am just giving you a simple idea here. Now the next one is, to say anything is handle, following two condition must be satisfied. Following two condition must be satisfied in order to say that it is a handle. What are the two conditions? The very first condition is path. Path is a sentential form that is completely matches with the right hand side part of the grammar production. Path. Path is a sentential form that is completely matches with right hand side part of grammar production. And the second point is, if handle is replaced by its left hand side non-terminal, that should leads to starting symbol. Means suppose if we are going with the path, suppose x x y like that, and xy is generated by suppose x, and then this xs is generated by s, then this path means this xy is generated this x, suppose. So this is called as path. Okay, so first condition is that path is a sentential form that completely matches with the right hand side, means it should be like that. X derives suppose xy like that, then path xy should be completely derived from the left hand side. Means suppose if x is derived xyz, then we can't do it like that, means it is not a path. But when we are getting exactly xy with x, means it is a path. And next, if we will proceed with the this string one by one, then at the end we must have to get starting symbol. If we are not getting starting symbol by following path, means it is not a handle, it is not a handle. Okay, so to say anything handle, these two condition must be verified. So I will take an example, very interesting example, and we'll also discuss get example so that you can understand the concept of this. Now important note is, no every matching string is not a handle, because ISRO has asked one questions with this point, so I had take it under this note. ISRO has asked directly a practical questions from this. I will also give you that question after the discussion of this theory session, and you need to solve this. But as of now, just make a note that every matching string is not a handle, because suppose many strings are many strings are matching with the grammar, but at the end if you are not getting the starting symbol, means you have taken somewhat wrong handle in the path. What I am saying to you now, it might be difficult for you in getting in real world, because I am discussing it theoretically, but when I will discuss it with the example, now you will get complete things completely complete things exactly, because we are presenting our e-lectures, right? In e-lecture, what the problem is that you are also facing a screen. I am sharing my screen, but when we are going with the offline classes, what do exactly have with the several example on the right hand side or left hand side on the board, we can discuss it. We can, you can also understand with the with our facing sense or with our hand, right? But here the problem is that you need to understand complete topic with the screen. But don't worry, I will share you all the topics. I will try my best to get you understand this topic, and don't worry, just focus on the theoretical concept once. And once we are going with the example, real time example, you will get each and every questions very clearly. We will discuss many questions, right? So don't worry. Now one more important theoretical point is, handle detection is the major problem in bottom up parsing. So you can just make note of it. Now next one is a very important question. First I am discussing with you, and rest of questions you will solve on the handle problem. First question is, how many number of handles are detected by bottom up parser to parse the following input by using given grammar? So we are having this grammar. What grammar we are having? We are having grammar S derives small x w, this S derives y, this W derives SZ. So the capital letters means this S, it is called as non-terminal. It is called as non-terminal. And capital W, it is called as non-terminal. All the capital letters are called as non-terminals, and all the small letters like X, Y and Z, they are called as terminals. Okay, so capital letters are called as non-terminals and small letters are called as terminals. Now we need to solve this question. And how we will solve this question? Our string is X, 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 Y and double Z. So initially this is the first question, so I am solving it. Focus completely on the screen. If after discussion of this question, if you are facing any problem, I will give you time to ask your all queries regarding this question, and after this question I will give you practical problems of GATE exam so that you can solve that. But as of now, just focus here. Question is, how many number of handles are detected by bottom up parser? Bottom up parser, you can also write BUP as of short form, BUP, bottom up parser. Okay, and we need to derive how many number of handles are detected by bottom up parser. So bottom up parser, one important thing I have discussed with you is it is rightmost derivation. I said na, when we will discuss example, I will discuss each and every point with you. So this is the statement that rightmost derivation in reverse order. So what does rightmost means? We need to start deriving our parse tree from the right hand side, and we need to do it bottom up, but in the in the fashion of bottom up parser. So you can say that it is right to left, and bottom up means right to rightmost derivation in reverse order. Why it is called as reverse? Because we are deriving from bottom side to up side and in reverse manner from right side. That is why this statement means a lot of meaning in it, and that is why this statement has asked in many kind of exams. Approximately all CS exam has once asked this question in theoretical form, that bottom up parser uses rightmost derivation in reverse order while constructing parse tree. So let us construct the parse tree. Now I need to match this Z. Is this Z can be constructed by any left hand side tree? No, Z cannot be constructed with any left hand side rule, because if you will observe here, S is generating X, X and W. Again S is generating Y, and then W is generating S and Z. But only Z is not be derived by any left hand side non-terminal. So I need to move from right to left side. Again I am facing Z. Do this Z is not again deriving from any left hand side non-terminal. So I again need to go here Y. So do Y is generating by any left hand side grammar? Yes, Y is generating with this S. So I can replace this Y with S. Okay, I am changing the color so that you can get it betterly. I am changing this Y with S. Okay, why I had do this? Because I can replace this Y with this S. This is called as handle. This is one of the handle, and I need to do this until and unless I get my starting symbol by reversing complete tree. Now again, if you will observe, I need to start from right hand side. Again I cannot derive Z from any left hand rule. I cannot derive Z directly from any left hand side, but I can derive this S and this Z. This S and this Z can directly be derived from W. So I can replace this S and this Z from W. So this is my second handle. So I am counting my handle 1. Initially this was the handle, now plus 1, because this is the second handle. Okay, now again if you will observe here, do I replace this Z and W? No, W and Z I can't derive. But if you will observe, after this X is left, I can't derive alone X with anyone. I can't derive this alone x with anyone, but I can derive x, this x and this w, this x and w with left hand side non-terminal s. So I can replace this with this s. So this is my third handle plus 1. This is my third handle. Again, if I will go, you can observe this s and this z. This s and this z can derive w, isn't it? This s and this z can derive w from rule number third. Rule number third. This is rule number 1. This is rule number 2. This is rule number 3. From rule number 3, I can derive s and z from w. So it is one more handle plus 1. So I have derived this z, this y, this x, this x. Now I am left with x, x and w. So this x, x and w can be replaced with s. This x and this w can be replaced with s. And this is my next handle, means plus 1. Now complete string is traversed. You can say that complete string is ended. Complete string is ended from right to left, from bottom to up. In this process we are getting 5 handle here, but at the end of this traversing, we must have to ensure ourselves that we are getting starting symbol at the uppermost level of parsing tree. If we are getting starting symbol, this is our starting symbol s. So if we are getting starting symbol at the uppermost layer, then we can say that it is correct answer, means total 5 handles are there. So these are the two rules. If handle is replaced by its left hand side, we are every time replacing handle. We are every time replacing handle with the left side, isn't it? So if we are replacing that every time, then it should lead to starting symbol. So this statement proves here. So you can say that at the end of our parsing, we are getting 5 handle and we are also getting our starting symbol, means our parsing is correct. Our parsing is 100% correct. And this tree is called as parse tree. This tree is called as parse tree. This tree is called as parse tree, which is the output of syntax analysis phase. It is the output of syntax analysis phase. So if we are presenting this as a token to the syntax analysis phase, this parse tree will be generated as output. So the gate question they have asked that if you are generating parse tree of the following string using this grammar, how many handles do we get? We will get 5 handles. Guys, is it clear? Just reply me. Is it clear to you? Just respond your feedback on the chat box so that I can go with the next question. Is it clear to everyone? Good. Saksham is asking one question. Is handle y sz or the string of is handle y sz or the string obtained? I am not clear with Saksham. Please clear your question. Yes, Sabrina, the left hand side non-terminal is the handle, means this s we have derived initially, this y. Again I am discussing, guys, just focus. Again I am discussing, just focus here. Our string was x x x x y z z. Your all concept will be clear. I have read every student's comment and I am again discussing it so that you all can get your 100%, right? This z, it cannot be generated from any left hand side non-terminal, so it is not a handle. This z again I can't derive it with any left hand side symbol, so it is not a, I can't generate any handle for this. But if you will observe this y, I can replace this y with this s. I can replace this y with this s. So this is called as handle. So this s to y, it is called as a handle. So Sabrina, you have asked that is the left side non-terminal is the handle, right? So yes, it is the first handle. You can say that it is the first handle while doing bottom up parsing. It is the first handle which we are getting. Okay. Now the second handle would be, again we need to start from right hand side, because bottom up parsing is right hand side and in reverse manner. So s to z it will be replaced by w. It is rule number 1, it is rule number 2, it is rule number 3. So from rule number 3 I can replace this y, this s and this z with the w, with this non-terminal. So my second handle is w derives sz. This is my second handle. So I am getting two handles till now. Again, if you will observe x, x and w, I can replace this xxw with the s symbol here. Okay, so it is my third handle. So what is my third handle? My third handle is s derives xxw. So this is my third handle. But you can't argue that, sir, we are getting starting symbol here, so can we stop here? We cannot stop here. Why we cannot stop here? Because the rule is we need to complete all string, we need to complete each character of the string. Until and unless we are not traversing each and every string, it is not a complete parse tree. Okay, now again this s and z can be replaced with w. So it is my fourth handle, and again this x, x and w can be replaced with s. So it is my fifth handle. So total 5 handles are there, and you can say that at the uppermost side we must have to get starting symbol, as we are getting starting symbol at the uppermost layer. So we are 101% sure that 5 handles would be there in bottom up parsing. Okay guys, is it clear to everyone? Ashik, I will discuss the concept of shift reduce parser with you once we are going with the, okay, we are going one by one. So when there is a need of shift reduce and reduce parser, we will go with that. And at the time of our reduce shift reduce or reduce parser, we will also take such kind of example. Okay. So if further any student have any kind of doubt, you can ask, because I hope you can get such kind of question in ISRO, BARC, or if you are facing IBPS, SO or NILET. Okay, in such kind of exam, such kind 1 to 2 question you may face. If interviewer is interesting in asking such kind of question, you may face such kind of questions, right? So I hope it is clear to you. Okay, now I am giving second question to you. Very, very interesting question. It is a gate question. Question is, how many number of handles are detected by bottom-up parser to parse the following inputs by using given grammar? Now, this question I am giving to you, and I am giving 4 to 5 minutes, because you need to generate handles and you need to generate correct handles, and after that you will form parse tree. And at the end of parse tree, if you will get starting symbol, you will say that this much handles are there in that, and this is the parsing tree. So guys, try it in your notebook, note this question, and solve it, because you need to generate handles and you need to generate correct handles every time. So question is, how many number of handles are detected by bottom up parser to parse the following input by using the given grammar? So you need to parse the string aaadbc by using bottom up parser technique, by using bottom up parsing technique. I am giving 4 to 5 minutes to each candidate. Solve this and tell me answer that how many handles it will detect, how many handle bottom up parser will detect. You can take the help of previous question and then answer. Okay, many candidates has answered. Someone has answered, Anjali has answered 9988999. Okay, try guys, try. I am requesting all the candidates to try that how many handles you are getting, because this is very important question of GATE. And if you are able to solve this question, means you are getting clear with parsing tree and parsing concept, right? Nikhil, please verify your parse tree. Jagdish, please verify your parse tree. Ashik, please verify your parse tree, because you may have generated the. Okay, very good. So sub Anjali has answered it correctly. Soumya has answered it correctly. Shonak has answered it correctly. Saksham is also answered it correctly. Sabrina has also answered it correctly. Okay, I am requesting the one who have getting 9 as a handle. Please verify the parse tree. Prasanna has also answered correctly and Jayashree has also answered correctly. Good guys, very good. Okay, so let discuss now. Rana has also answered it correctly. Good. So if I started with the left rightmost side, you can say that this C, I can generate this C. This is basically all are terminals, all are in small letters. So I can generate. Okay, let me change the color so that it would be better. This C I can generate with this C. Okay, so this is my first handle. Okay, guys. After that, I can generate this B and C with the capital B. So this is my second handle. If I again go D and B, I can generate this D and B. Okay, for helping you out, this is rule number 1, this is rule number 2, this is rule number 3, this is rule number 4, this is rule number 5, and this is rule number 6, so that you can get it clearly. So I can replace this D and B with capital B with the rule number 5. I can say that. So this is my handle number 3. Now I can generate A or B. Okay, I can't generate A and B. I can only generate this A with the capital A. I can only generate this A with the capital A, and you can say it as a handle number 4. And I can further generate. I have completed this C, this B, this D, and this A. So I can replace this A and this B, this A and this B with rule number 2. Means I can replace it with S. So this is my handle number 5. Again, if I will go, I can replace this A with the A, because I need to traverse from right to left. So this is my handle number 6, and I can replace this A and S with capital S as a non-terminal with the rule number 1. I can say that, and it is my handle number 7. Again, I need to replace this as a with the capital A, that is non-terminal, with the rule number 3, and it would be my handle 8th handle. And again, A and S, it would be replaced by rule number 1, and I will get starting symbol here, and this is my 9th handle. So I have traversed all the strings C, B, D, A, and after traversing each string, I am getting my starting symbol, and in that process I am getting 9 handles. I am getting 9 handles. So guys, is it clear to all of you? In this question, do any candidate do have any kind of query or any kind of doubt? Because this is the GATE question, and if they will modify such kind of questions with any kind of grammar, I hope you will solve it, right? So do any candidate have any kind of queries in that? Clear? Okay guys, next question, question number 3. It is a ISRO's question, and it is very conceptual question guys. I am getting you, the topper of GATE can also fail in that question. So just focus on this question. It is completely depend on parsing tree, and it is very conceptual question. Basically in ISRO's exam, it will be placed in the hard level question. It will be placed in the hard level question, and you will get concept with this statement. You will get concept with this statement. What statement? This statement: every handle string is not a handle. This I already discussed with you that this statement was asked as a practical in ISRO's exam. every matching string is not a handle, so be careful while parsing the tree. Be careful while parsing the tree. Okay, solve the question number 3. I am giving you again 4 to 5 minutes because it is a hard level question and you need to parse it very carefully. The question is, which of the following are sequence of the handles detected by bottom-up parser to parse the input? Your input this time is n plus n multiply with n. It is your input string by using following grammar. Okay guys, this is the grammar given to you and these are the 4 options. I am giving 4 to 5 minutes to each candidate so that you can solve it very carefully, and if you are solving this means your parsing is clear, then we can move for the next topic because it is the uppermost question from the parsing technique and you all need to solve it. 4 to 5 minutes I am giving. Just comment that which option you are getting. So I hope question is clear, that which of the following sequence you will get while parsing. Here you need to tell me that which sequence you are getting while parsing the following input using this grammar. Okay guys, solve it. Okay, so many candidate has answered. Anjali has answered, Thaya, Hardy. Okay, do solve it guys. Do solve all the, I am requesting all the candidate to solve because your interactiveness with us is very matters, because as much as you will interact with us while solving the question will increase your confidence. Just answer, just try and answer. If you are getting doubt while solving, you can ask, sir, I am getting doubt in this step, how to solve now. Okay, but at least solve the question. Okay Manjit. Okay, so I will solve this question. Don't worry Manjit. I will tell you, okay? Don't worry. Shaksham has answered it correctly. Shonak, please check once again. Rana has answered correctly. Paushali is also answered it correctly. Nikhil, please verify once again. RD, Sabrina, Piyush, Thaya, Anjali, they also corrected the. They also give the answer correctly. Good guys. Correct answer. Okay. So most of candidate has answered, but many candidates are also getting problem while solving this question. So don't worry, I am giving you time here. Now let's solve it like that. I will scan every statement so that concept of parsing will again clear to you. I am again giving a simple example that our input is n plus n into n. Now the question is we need to solve it using bottom up parsing. Bottom up parsing, you know, right to rightmost derivation in reverse order. Okay, so if I go with option A, because I want to tell you something, that why option A, B or C, why if one is correct, why the other one is not one, right? Not correct. So n plus n and n into n. So basically you directly say that if you will replace this n with this e, if you will replace this n with this e, so basically here is a keyword mistake, you can say, because this n plus n and n into n, you can't do that, right? Because either you can take e plus n, either you can take e into n or n, right? So for your easiness, I am writing the grammar like that. E derives e plus n, suppose it, and e derives e multiply with n, and e derives n. This is the rule number 3, this is rule number 2, this is rule number 1. Okay, we can write this grammar like that. Okay, don't worry. So if I will option A is itself wrong, you can yourself say it is itself wrong, because here we don't have any kind of terminal here, right? Non-terminal here, it should be there because it is n plus n and n into n, it directly, it is not a part of the grammar, right? Now if I go with the option B, that is e plus n, e plus n, so e plus n. Okay, if I will move like that, and if I will go with e plus n, but for e plus n I need to derive this n na. I need to derive this n with this e, and then I will derive e plus n with e. But if I directly choose e plus n, it is not possible for me, that how should I derive e plus n directly, because for getting this e I need to derive this n. That is why you can say first I will need to derive n, but which n, it is also important task, n plus n into n. If I go with the left to right, right to left, n, suppose I am deriving this n with this e, means what I have derived first, they are asking us the question that e, if I have derived this e with that, then n into e, n into e, n into e is not a part of our grammar, n into e is not a part of our grammar, so I can't derive this n first, I can't derive this n first. Okay, now means this n I can't derive because I need to, I don't have n into e in my grammar now, so I need to derive this n first, means it may be like e into n now. So if e into n I will perform here, okay, if I will perform e plus n here, and if I will replace with this e, then again I don't have n plus e in my grammar, so I am only lefting with the option C, means like that I am only left n plus n into n. We have checked two examples, that first we have, this is the first case in which I have derived this n first, I have executed this n first, but I am not getting my symbols there, that is why it is the wrong option. Then I have derived by by deriving this n, but still I am not getting my starting symbol because n e is not a part of it, so this is also not an option. So I am only leaving with the option that this n I need to derive first, so I will derive this n with the e, because this n can be derived with this e. Now I can derive this e plus n with e, and then I can derive e plus e into n with the e. Okay, so first I need to derive this n, I have derived this n, then I derived e plus n, so my second handle is e plus n, e plus n, and my third handle is e into n, e into n. So option C is the correct, because if you will go with e plus n firstly, you are itself not able now, how you will derive e plus n until and unless you are not getting non-terminal. ओके, बनी सेइंग मुझे ग्रामर नहीं समझी थी, अभी आया समझ में। ओके, अगर अभी आ गया समझ में, वेरी गुड। अगर अभी भी किसी को डाउट है दैट व्हाई ऑप्शन सी इज करेक्ट, यू कैन आस्क, बिकॉज हमने क्या किया, मैं आई एम रिपीटिंग, डोंट वरी, आई एम रिपीटिंग। Okay, sir, here why aren't we doing right to left? We are first doing the leftmost. Yes, yes, yes. Shonak, your answer is in this statement. Your answer is in this statement, Shonak. Every matching string is not a handle. Every matching string is not a correct handle. Basically, you can modify it. Every matching string is not a correct handle. It is a handle. If I will do left to right, okay, where is the question, guys? Here is the question now. If I will do left to right, if I will do right to left, if I will do right to left, okay, Shonak and Somya, please focus on this question again. I am requesting Shonak and Somya. They are asking, sir, why we are starting from left. So the important point is every handle is not a correct handle. Even though we can derive like n plus n into n, and if I will derive from right to left, so in right to left I can derive this n with e, but now can I solve it n into e? I don't have any grammar n plus e. I am not, means after deriving this n with e, after deriving this n with this e, how can I go further? I can't derive n into e because e into n, it is different n into in recursive grammar. If you have knowledge in recursive grammar, e into n doesn't equals to n into e. First thing is that it is a rule number one, you need to focus here. Okay, it is the rule number one that e into n doesn't equals to n into e in terms of bottom up parser. In terms of bottom up parser means context free grammar, it is not equal. So you can't say that e into n is like that, because here n into e I am getting, and n into e is not a part of my grammar. That is why I, even though I can start from right to left, but I can't complete my parse tree. That is why I need to change the option, and that is why I can go with n into n, and I can go with this option. But even though I am getting e here, means I didn't derive my left hand my right hand side element. But now again, if you will go right to left, means e into n here, it will replace with e, but again you are getting stuck that n plus e doesn't exist in my grammar. That is why I need to go with third option. And what is my third option? Third option is first derive this n. So if you will derive this n, means n plus n into e, if you will derive this e, now it is okay. We can derive e plus n, because there isn't n into e, there isn't anything like n into e. So I forcefully need to go e plus n first, and I then need to go e into n here. So this is e. So this is the option. That is why n, then e plus n, and e into n, it is the correct. So guys, is it clear to you now that why we are going left to right in this question? That is why this is the ISRO's tough level question, because every handle is not a right handle. They want to clarify this concept. They want to check your this concept. That is why they have asked this question from you. Again, if anybody, okay, Ashik clear nahi hai, please show the slide of the every matching string is not a handle. Please show the slide of every matching string. Okay, it was just a theoretical point. It was just a theoretical point here. Every matching string is not a correct handle, because for the perspective of ISRO I have discussed that point, right, Ashik? That is why I have already mentioned before discussing this question that on this concept ISRO has asked one question. And if you will go right to left now, if you have go right to left, you will get you will get you will not get initial symbol at the uppermost layer. That is why you forcefully need to move one step ahead. Again, you are not getting initial symbol at the upper level. That is why you need to start from left to right, and that is why option C is the correct. So by following this step, you can grasp 3 marks in the ISRO exam. So guys, is this clear now? Is this clear now? Please respond. Okay, okay. Is it clear to all guys, right? Okay, guys. So as of my instruction, do you need a 5 minute breaks, guys? If you need 5 minute break, then just show your response so that we can resume our session after 5 minutes, because it is 1 hour completed. And if you need 5 minute break for relax, okay. So what's time it is? It is around 5 now. We will resume our session from 5:05 p.m. Okay, I am giving you 5 minute break, and then we will start next topic. Okay, guys. So
Give break, sir.
okay, sir. Okay.
Hi Rahul sir.
Yes, sir. Shall we start?
Yeah sir. Just a
Okay.
minute sir.
Okay, sir.
Sir you can start sir.
Okay, okay. So, guys, are you ready for next slide? Please show me response in chat box so that I can proceed with that. सर ने तो कल ही बोला था. Okay, जल्दी जल्दी सब. I am requesting to all that please come online as early as possible so that we can go with our next slides. Okay. Is other candidates ready? I am getting only one response. Only one candidate is ready yet. Is other candidate is also ready so that I can start? Please response. Okay. Okay. So guys, now some important points are there, which is based on the parsing techniques, and it is a theoretical concepts, which we will further clear with next questions, right? So some important points are like all bottom-up parsers are shift-reduce parsers, and you can also write shift-reduce parser as a SR parser, as a SR parser. SR parser means shift-reduce parser because parsing is done with the help of shift and reduce action. Shift and reduce action, what does shift and reduce means? Shift action means moving the symbol from input buffer to the stack. As I said now, that we are traversing these elements, like we are traversing a d b c, so we are parsing the tree, but we are parsing tree manually. We are doing it manually, but computer will not do it manually. Computer will do it with the help of data structures. So one by one it will place the input character into the stack. One by one it will place into the stack, and then they will compare the parse tree, because we are making parse tree like that we have replaced this like that, and at the starting point we are getting our starting symbol. But computer will not make such kind of parse tree now, because all is going on the binary digits. So computer will use data structure. What data structure computer will use for parsing? Stack. It is also important question, right? So that is why the point here is shift action means moving symbols from input buffer to stack. And reduce action, what it means if a handle is matched with the left hand side, then it will replace with the left hand side non-terminal. It is means reduce. So whenever we are replacing left hand side, suppose we are getting s xy, so if we are getting this we are matching xy string in our input string, then we are replacing it with this x, so this replacement is called as reduce. And checking one by one string, it is called a shift means putting string into the stack so that we can check. And if they are matching, we are reducing means putting outside stack, popping off. So this is the procedure of shift and reduce. That is why all bottom up parsing techniques, all bup techniques, all bottom up parsing techniques are shift reduce parsing techniques. And shift reduce and shift action and reduce actions are clear with these statements. The next one is, if there is a handle in the stack parser, if there is any handle in the stack parser, then parsing will be performed by reducing the action, otherwise it will perform shift action. Okay, so it will better be clear by example. And the next one is, if the input is ended and stack contains a starting symbol, then accept action is called. Means if all your strings are completed, and at the end if you are getting starting symbol in the stack, means your parsing is correct and it will be accept. So accept action will be taken place there, right? So these are some important points from the parsing techniques. And now question number 4, very very important. The question is, how many shift actions and reduce actions taken by shift reduce parser to parse the input 4 times x y z z by using given grammar. So grammar is again given to you. It is the same question which we have discussed earlier. Now the question has changed. You need to answer how many shift actions are there and how many reduce actions are there. In the definition of shift action and reduce action, I have already told you. Shift action means when you are putting the symbol into the stack, it is called a shift action. And reduce means whenever you are getting handle, it means it is a reduce action. So can you answer me guys that how many shift actions are there and how many reduce actions are there? I am getting 2 minutes. It is very easy question, very easy question guys. Even though I am giving you 2 minutes, just tell me how many shift action will be there and how many reduce action will be there in order to parse this string using the given grammar. Yes, the grammar is same. Sabrina is asking for previous slide. This slide guys. Sabrina, are you asking for this slide? Okay, the question is this. How many shift actions are there and how many reduce actions are there? Just tell me. Okay, most of the candidates are answering question correctly. But I am requesting that answer it that how many shift and reduce like shift. Okay, Bunny has answered it. Very good. Very good. Okay. Good. Anjali has also answered it correctly. Nikhil, Soumya, Bunny, they again have answered it correctly. Good. Okay. So, but my perspective of asking this question is somewhat different. Why I asked this question now to clear all concepts of you. How we need to start now? We will start like that. We will start like that. What is my string? So my string is I will take stack. I will take help of stack this time. I will take help of stack this time, and I will take my input here. Okay guys, and I will count that what action it does. I will count what action it does. So at the initial, what is my input? My input is x y and double z. Okay, and at the end I will place this dollar. This dollar is basically signifies end of string. What it is signifying? It is signifying end of string. That is why I have put it, because in the real time this scenario happens. That is why you can get clear with that. That is why I have put dollar here. It is our initial. At the initial step I have empty stack. Empty stack means a stack is only containing dollar. Dollar means it is an empty stack. Okay, it is my empty stack. Just to clear you these concepts, shift action, reduce action, so that when we will discuss parsing techniques now, you will get clear with that. That is why I have taken real time example that how computer actually perform parsing. How computer actually perform parsing. Now in next step, what computer will do? Computer will what it will do? It will put, I have dollar in it. It will shift one input one by one. It will shift one input one by one. It had put x here. So what my string is now? My string is only left with x y z and dollar, isn't it? So what action I had did now? I had put this screen it. I had shifted it because I have shifted the input buffer into the stack. I have shifted the input buffer into the stack. So my action is shift action. It is my shift action. Here stack was empty. Now in the first step I have shifted the element. In the second step, now my stack is like that. I have x element in that. Now Can I reduce this x with any left hand side? I cannot replace this x, means until now I can't reduce it. I can't reduce it with any left hand side non-terminal. So what I need to do, I need to further shift one more element. So now I have shifted this element as well. So what input now I have left with x, y, z, z and dollar. And what action I have performed? Again I have performed shift action. Okay guys, now the next one is, again I need to take dollar is here, x is here, x is here. So can I replace this double x with any left hand side grammar? No, I can't replace double x with any left hand side non-terminal. So again what I need to do, I again need to shift the next input buffer into my stack. So I have again shifted the next input buffer into my stack, and now my input is left with x, y, z, z and dollar. So again I have performed what I have performed, shift action. Okay guys, now again my stack will look like that. At this time my stack is looking like that, x, x, x. Now can I replace this x, x, x? Now I can't replace this x, 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 because I don't have any left hand side non-terminal whom I can replace with triple x. So what I need to do again, I need to put this x again here. So now my input is looking like y, double z and dollar. So what I did here, again I have shifted here. Okay guys, now I am taking, because due to less space here, I am taking the help of next slide. Now again in the next step, what will happen? Dollar is here, x is here, x is here, x is here, x is here. I can't replace any x with the left hand side non-terminal. So I will again shift the next input symbol, that is y. I have pushed y into it. So now my string is input is remaining with z, z and dollar. So what I did now, again I have shifted. So till here this is the condition. So let it write it here. My stack is looking like dollar x, 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 x and y. It is the previous one, right? This is, I am repeating this one. My input string is now z, z and dollar. This dollar is signifying ending of a string. And what action I had performed there? Shift. So I have repeated this string. I am rewriting it so that you can't get confused. Okay, now at the next step I can reduce this y with the rule number 2, isn't it? So now what I will do, I will reduce this, means I will pop up this element, I will pop up this input element, means now my stack will look like dollar x, 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 and with whom I have replaced this y, I have replaced this y with s. So I have replaced this y with this s. So I need to put s here. So what I did, I replaced this y with this s. So this is called as reduced action. So this is the reduced action. Okay guys, now my string is again left with z dollar. I hope you are getting clear with this until now. At the time when you have parsed this string now, first parsing you have done with this y, isn't it? So you can recheck it, that in computer it will be look like that. It is getting right to left, but in computer actual procedure will be like that. Now in the next stage, can I replace double x s? No, I can't replace any string. So what I need to do, I further need to I further need to shift one more z to here. Now my string is left with z and dollar, and I have performed shift action here. Now can I replace? Yes, I can reduce this s and z with rule number 3, that is with w. Means I can replace this s z with w. On the place of s and z, I had reduced it. So sorry, okay, so in this step I have shifted it. So in my next step, what I will do, dollar x, 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 x and s z, it is reduced with w. So now my string is z dollar, and now I have performed reduce action, so I had write it rar. Now again I can reduce this xsw with rule number 1, that is s. So my next condition would be like dollar x x x x, okay, x on the place of xsw, what I need to do, s. So what I did, reduce. Again, do I replace anything? No. So I need to shift this into the stack. I need to shift this input buffer into the stack. So now the condition is dollar x x s and this z. So now dollar is left, and this action I have performed is shift. This dollar is signifying me that I have read all the string, all the input characters. So I do not need to read any string now. This dollar is signifying me that. Now I just need to check that whether I can reduce something or not. So I can reduce this s and z with rule number 3. So now my stack is dollar x x and s and z is replaced with w. So this is my reduce action. And in the next step, x x and w will be replaced with rule number 1, that is with starting symbol. It is again reduce. Now I am getting starting symbol at the last position because I don't have anything now to shift. I don't have, because at the input symbol I have dollar. Dollar means I have scanned all the input buffer. I have scanned all the strings, means I do not need to shift anything, and at the end I am getting starting symbol, means this is the correct way of parsing. This is the actual parsing what compiler will do with using stack as a data structure. So I hope you got the concept in detail. Now let's just count reduce and shift action. 1 reduce, 2 reduce, 3 reduce, 4 reduce, 5 reduce. I am getting 5 reduce. How many shift? 1 shift, 2 shift. This is repeated na, so 2 shift, 3 4 5 6. Okay, 1 2 3 4 5 6, and one more is there, right? This is one more, 7. So total 7 shift and 5 reduce action are there in that. Okay guys, so are you clear with shift and reduce action here or not? And due to shift and reduce action, we can say that bottom up parser technique is called as shift reduce parser. Why? Because we are doing shift action and reduce action every time. So this is the exact procedure what compiler will do in real time. We basically are doing it manually, but compiler will do exactly like that. So if you will observe here, when we have solved this question here, first we have reduced this y. So our first reduce here is also this y, isn't it? This y was the first our reduce. So this is the exact procedure. This is done in the right to left, means in rightmost order, and in reverse order. That is why this point makes sense. That is, bottom up parser uses rightmost derivation in reverse order while construct the parse tree in real time as well, in compilers also, right? So I hope it is clear to you now. Okay guys, clear? Okay, all candidates has responded. Very good guys. Now the next question I am giving to you. You need to solve it. It is a ISRO's question. Very important question from the shift reduce action. Question is, how many shift actions and reduce actions taken by shift reduce parser to parse the input I plus I dollar by using given grammar? Don't get confused with dollar. This dollar is just signifying the ending of string. Okay, so just give me the answer that how many shift action and how many reduce action you are getting. I am giving you 3 minutes to answer this question. It is very important question, and you may take 4 minutes because it is a hard level question. So just focus on the grammar, just focus on the input string and solve step by step as I have solved in front of you. I just need to answer you. It is ISRO's 3-mark question guys. It is ISRO's real-time 3-mark question. So if this kind of questions are in GATE exam, you need to solve there. So just apply your approach and answer me that how many shift action and how many reduce action you are getting. Then I will tell the answer that what is the correct answer. Okay, I am giving you the option A. Total shift actions are 3 and total reduce actions are 3. Option B. Total shift actions are 4 and total reduce actions are 5. Option C. Total shift actions are 3 and total reduce actions are 3 okay 4. And option D, none. So out of option A, option B, option C and option D, which is the correct answer, guys? Answer me. How many shift actions and reduce actions are taken place by the following grammar for the following input? It is very interesting question. Very interesting question. Recheck your answer, guys. Recheck. Please recheck the answer. Please recheck the answer. Okay, I am asking one question meanwhile, that whether this string is perfect string to traverse using this grammar using shift reduce parser. Many candidates answered. Almost all the candidates is answering the question. Very good, guys. At least you are trying. It is very good. You are putting your efforts. Very good. Because when I will discuss the solution, you will find it very interesting because some concepts are hidden in it and you need to explore that concept, that how to answer such kind of questions. And why I discuss the method, why I discuss this method now, why I discuss this stack method is important. Okay, now I am solving the question. The question was how many shift action and reduce action taken by shift reduce parser. Okay, so many of you have answered 1 1 2 2 and many of, okay, no, okay, so let's focus on this. Initially, if you will observe, my stack will look like that. Dollar will be there and I have empty stack and my input string is I plus I and dollar. And what do I have? Initially I don't have any action. Now in my next step, okay, let me change the color. In my next step, what I will do, I will shift this I. Okay, as I have shifted this I, so I can say my input is now remain with plus I and dollar, and action that I have performed is shift. I have performed shift action here. Now again in my next phase, what I will do, in my stack I have dollar I. So can I replace this I? Yes, I can replace this I. With whom? With T. With T I can replace. So I have reduced this with T, but my string is remaining itself and I have performed reduce action. If you will observe, again I can reduce this T, again I can reduce this T with E. So what I will do now, I will reduce this t with e. Now my string is remaining as it is. My string is as it is. Now it is again a reduce action here. Now can I reduce this e? No, I can't reduce this e now. So what I will do, I will shift this addition here. So it would be like dollar is here, e is here, and plus is here, and my string is now I and dollar. And what I did, I put a shift action. Before that I have performed one shift and two reduce. So now it is second shift. Now I can't reduce e plus. I can't reduce e plus now. Okay, so what I will do now, dollar e plus, and I will I also need to do it shift. So I will shift it I here. So I have shifted e plus I here, and my string is now empty. So again I have performed shift action. Now in the next step, can I replace this I? Yes, I can replace this I with t. I can replace this I with t. So what I will do, e plus t, e plus t, isn't it? Because I have replaced this I with t, means what I have do, I have reduced here. I have reduced here. Now what I need to do in my next step, dollar, in my next step, you can say here, what you can say, that here I have shifted I, here I have shifted here I have reduced I with t, here I have shifted e with t, but now there is a confusion. What confusion? That suppose e plus t, you can reduce that e plus t. Okay, e plus t I am lefting with e plus t, right? So e plus e is also there, because I have reduced there. Suppose I have reduced this e plus e. Okay guys, e plus e, but I am not getting my initial symbol e. I am not getting my initial symbol e. I am not getting my initial symbol e. Are you getting why I am not getting my initial symbol e here? Because if I am performing these steps, then at the end, if I am not getting my starting symbol, means our parsing is not correct. Why our parsing is not correct? Because in this step I do have two options, that I can replace this t with e, or I can also do like that. Once I have reduced I with this t, I can also do like now t, and I can shift this plus. Means I have confusion here. What confusion I am facing here, that whether I shift this addition operator here, or whether I reduce, because it is a chance that should I replace it or should I add a next element. So due to this this confusion is called as shift reduce conflict. This confusion is called as shift reduce conflict. And what is shift reduce conflict? Shift reduce is conflict, that is, we are confused that whether we need to derive it once again or we need to add a next element here. And due to this shift reduce conflict, the correct answer that ISRO has provided was D, none, because we are facing shift reduce conflict here. So this is the process. What is shift reduce conflict? The next definition is shift reduce conflict. It is a situation in which both shift action and reduce actions are possible. As of here, you can say here shift is also possible and reduce is also possible. So parser is unable to decide which action to perform. That is why it is called as shift reduce conflict. Okay guys, and the next one is reduce conflict. Okay, I am getting some problem with my pen. Why there is a pen problem in pen? So I am getting shift reduce conflict, guys, and due to this shift reduce conflict, due to this shift reduce conflict, due to this shift reduce conflict, the correct answer is D. So is it clear, guys? The concept of shift reduce, the concept of shift reduce conflict is clear to you? स्ट्रिंग गलत नहीं है, स्ट्रिंग गलत नहीं है, मतलब हमको शिफ्ट रिड्यूस पार्सर से हम वी कांट सोल्व इट यूजिंग एसआर टेक्निक, शिफ्ट रिड्यूस से हम सोल्व नहीं कर सकते हैं, तो हमको किससे सोल्व करना पड़ेगा? वी नीड टू डू इट समथिंग एल्स. What we need to do it something else, I will discuss it later, but as of now, if they have asked that using given grammar, using shift action and reduce action you have to perform, then the correct answer would be option D. So this is the process, this is the problem of shift reduce action. Okay, now the next one is, I'm getting some problem with my e pen, I don't know why. Okay. Just 2 seconds. Reduce conflict. What reduce conflict is that? Okay, Shonak is asking that please explain. Okay, I will explain it again, don't worry. Reduce conflict is, it is a situation in which handle matches with the multiple productions of right hand side part, then parser confuses that which means, suppose there is a two possibility of reducing, that then parser will confuse that whether I have to reduce it this one grammar or this one grammar, that is called as reduce grammar. And shift reduce conflict is the condition here, that in that process, suppose I am doing here, actually I am getting problem with my e pen, I don't know why I am unable to write. Just 2 seconds, guys, there is a problem in e pen. So here if you will see, it was our stake, initially dollar was there, e plus I, when I putted I, when I shifted I initially, I have possibility that I can replace this I with this grammar, so I have replaced this with T. But now I have possibility that I can add I can for the first one na dollar, then for first I replaced it with E. Now I have possibility that I can add a plus, but I have one more possibility that I can reduce this E with T. I can reduce this E with T. Actually problem is there in the pen, and due to this problem I said that shift reduce action is there, shift reduce conflict is there. Okay, so what's problem in that? In that we are calculating handles only, not shift reduce action. Okay, so actually you need to do it like that. Actually the question was asked by ISRO just to check your concept, that whether you are checking it with the concept of shift reduce parsing or not. Means we need to modify our techniques, we need to check handle with other process, we need to implement something else in it, right? So we need to check handles, but question was on the basis of reduce action and shift action. So whenever they ask questions like shift action and reduce action, follow stack procedure. What I am giving advise you, that whenever they are giving you shift action and reduce action problem, what you will do, you will follow stack procedure. And whenever they are asking you handles, you can direct go with the parsing. Okay, guys. Aishik Shet is asking, shift reduce operation was not mentioned in the previous question, n plus n into n. Yes, that is why we have checked all the option na, and only C option was left with us, in which our starting symbol are getting. With the first two option, we are not able to getting the starting symbol in the question. That is why we have go to the option C there. Many students are asking in this question. In this question, first two options, in from first two options we are not able to find starting symbol. That is why we had got to the C. But in that question the concept was around handles. That is why we have answered C. But in this question the question is around shift action and reduce action. That is we have chosen option D. Is it clear now? Is it clear, guys? If anybody have problem in this question, please ask me. If anybody still have problem in this question, please ask me. Okay, so I can move forward now. So there is an important definition of shift action and reduce action. So you can note it. You can note it, guys. You can make a screenshot of it. Okay, my pen issue is fixed, guys. Don't worry. I will give you 5 minute break. Just a couple of minutes after, right? Just wait. Okay. Just let us complete the theoretical concept first, so that we can complete our today's topic. Okay. So the next slide is on the LR, the information I am providing you. The important points are the LR parser is a non-recursive shift reduce bottom up parser. It uses a wide class of context free grammar, which makes it the most efficient syntax analysis technique. So what information I am adding to LR parser? It is non-recursive, it is shift reduce, and it is bottom up parser. This is the question asked in Bark CS. It is the point I am taken from there. I taken from there that LR parser is non-recursive. It is a shift reduce parser and bottom up parser, right? Some added information I have provided to you. Now we will focus on LR parsing algorithm. That what LR parsing algorithm is all about. So LR parsers are also known as LRK parsers, where L is stands from left to right. Scanning of the input string means we need to scan the inputs from left to right. R stands for construction of rightmost derivation in reverse. Construction of rightmost derivation in reverse order, as we did in our parsing tree. And K denotes the number of look ahead symbols to make the decision. It will get clear to you with the example, right? But as of the information point of view, you can note that there are basically three widely used algorithm available for constructing an LR parser. SLR1, that is simple LR parser. Actually this is the talk of letter, this is not of talk of here, but just for your information point of view, you can make a note of it. SLR1 is simple LR parser, it which works on smallest class of grammar. Another point I want to add to here is few number of states are there in SLR1, hence very small table is existed, and SLR1 is simple and fast construction. If I talk about LR1 parser, that is LR parser, it works on complete set of LR1 grammar. It generates large table and large number of states. And LR1 parser is slow construction, it is slow. The next one is LALR1, that is look ahead LR parser. It works on intermediate size of grammar and number of states are same as of SLR1. So number of states in SLR1 will be same as of LALR1 in talk of number of states. Now as of here I think you are not aware with number of states how to construct DFAs and like that. So this slide is a talk of letter, we will discuss. Basically this is a comparison slide of various parsing technique. We will discuss it once we will complete this all techniques, right? Now here is a picture of LR parsing algorithm data structure. In LR parsing data structure you need to do, basically computer will do with the help of stack data structure. Input string will be scanned from left to right, one string at a time. Parse tree will be constructed under this box. Syntax errors, if they have any syntax error, it will be presented in that box. And our parsing table will be look like that. It is the structure of our parsing table. It is the structure of our parsing table. Our parsing table will be look like that. It will have two options. One is action state, and other is go to. Action will consist shift, reduce, action or error. S denotes shift. R stands for reduce. A is accept, and E stands for error. And go to will contain next state. And here states of DFA will be mentioned. It is the structure of LR parsing table. LR parsing table structure will be look like that. You can take a note of it, you can make a screenshot of it, no problem. But it will help you a lot when we will do the question, when we will verify the following grammar is LR grammar or not, then it will be required there. So I will discuss it with the very important example, and then you can get aware with that, right? So we are discussing that how to construct LR parsing algorithm. So there is basically some theoretical concepts which I am discussing with you, and then we will discuss gate questions on LR parsing. Okay, so initially we need to push starting state of parsing table into the stack. Whatever starting state of the parsing table will be there will be put into the stack. Okay, well, please show the diagram. This is the diagram. You can make the diagram. If someone is noting, jotted down or making notes, you can make the diagram, and then we will move to the next slide. Okay, Anjali, I will go a bit slow, don't worry. Okay, don't worry, I will follow a bit slow, don't worry. Okay, don't worry. So this is the parsing algorithm. So guys, you are noting down this diagram. A means accept state. A means accept state. S means shift. R means reduce. A means accept state. E means error state. Okay, make a diagram of it. It is very important for making LR parsing table. Basically, it is the strategy of compiler, that how compiler do. And LR parsing table is the use of us, that how we will do. Okay, so can I move to the next slide, guys? Sir, can you show the slide of conflict? Okay, Soumya, this is the slide of conflict. You can make a note of it. You can make a note of it. Okay. So can I move to the next slide, guys? Okay. So now we are discussing the basics of LR parsing algorithm. In LR parsing algorithm, what computer do now? We are just discussing that how compiler is doing in real time. Then we will do that what our need is. So first we are discussing according to the need of compiler. Initially, there is a need of pushing starting state of the parsing table into the stack. Suppose our starting state is S. So there is a need of pushing this starting state into the parsing table. We will first put starting state into the parsing table. Sure, Suez. I will share all the notes with the sir. Don't worry. Okay. And next one is let S is a state or top up state, and A is look ahead symbol. Parser takes decision from LR parsing table as follows. If action table entry S to A is accept, then input is valid and parsing is successful. Okay, so there is some theoretical point. So I am requesting all of you, this is some theoretical point, so just take a screenshot of it. Let us discuss it with the example, and then we will come up again to the theoretical point so that it can be clear better to you. Okay, so take a screenshot of this one as it is a theoretical concept. take a screenshot of this one. This is the next slide. Take a screenshot of this one. This is the third slide for LR parsing. Because it will be better that I first clear your real-time example, then we will come up again to the theory. Okay, so it will better for you to understand it exactly how LR parsing algorithm basically works. Okay, okay, so our example is like, suppose the question is construct LR0 parsing table for the following grammar. Suppose you are having this grammar S derives AB. This is rule number 1. Rule number 2 is A derives A, and rule number 3 is B derives B. Okay guys, our question is we need to construct LR0 parsing table. We need to construct LR0 parsing table for it. Now how to construct LR0 parsing table? Step 1. What is step 1? Construct augmented grammar by adding new production S dash to S. So suppose our grammar is S derives AB, A derives A, and B derives B. So what is step 1? We need to add one more new production into our grammar, and this new production is called as augmented grammar. So I will do S dash derives S. I need to add it. I need to add this new production. It is the step 1. It is the step 1. The advantage of adding new production is to get accept action in parsing table. So in parsing table, when our string will get accepted, it is the advantage of this adding new states. How it will be look like in parsing table? When we will generate parsing table, when we will design parsing table, at that time it will be clear to you. So this is step 1. What is step 1? Add a new production S derives S, like that in our grammar. Now step 2. Step 2 is construct LR0 items DFA by using closure function and goto function. Now we need to construct what we need to construct. We need to construct DFA item, LR0 items DFA, that is deterministic finite automata. We need to construct deterministic finite automata by using closure function and goto function. By using closure function and goto function. So don't worry, I will make this and will explain you from that. Step 3 is LR0 item. Now what are LR0 items now? LR0 items is nothing but context free grammar productions having dot on the right hand side part. So suppose my grammar is S derives S, S derives AB, A derives A, and B derives B. So this is not LR0 item. LR0 item is I need to add dot. I need to add this dot on the right hand side before the right hand side production. This is my LR0 items. This is my LR0 items. Okay guys, this is step 3. And what is step 4? The LR0 item S derive A dot means अगर ऐसा LR0 item आपके पास आ रहा है, if you are getting S derives A dot B, it means that parser has seen A, and it is ready to see B. Means parser has seen A and it is ready to see B. In any LR0 item, left part of the dot is present in the stack. In any LR0 parser, the left side of dot means suppose S derives A dot B. What is left side of dot? A. इसका मतलब है it means that A is already seen by parser, means it is presented inside the stack, and right hand side of part is ready to go into the stack, and right hand side part of dot is ready to come onto the stack. It means like that. Step 5. The LR0 item in which dot is at the rightmost side end leaves to reduce action. Means if our state is like A B dot, it means that parser has read out both the strings, all the strings, and it is now ready, to reduce, means now we can reduce AB with S. We can reduce a string with the left side non-terminal. So if we are getting this dot at the rightmost end, means we can reduce it now. These are the 5 steps. Now there is a need of understanding closure function and goto function, and after that I will try to draw the parsing table for you. I will explain one example with very detail with each step, that how to perform each step, and then you will solve the gate question. Okay, but before that let us discuss some important terminologies of LR parsing table. The very first one is closure function. What is closure function? In any LR0 item dot existed, then closure function adds that non-terminal function and puts dot in the first position of right hand side part. इसका मतलब क्या है मैं आपको बताता हूँ. Suppose a grammar is like as derives a dot b, means closure function is saying that according to rule we need to add all the transitions of b now. So our transition of b in the grammar is b derives b. So if this dot is existed before any non-terminal, the rule is if this dot is existed before any non-terminal, then we need to add closure function, before that non-terminal in that state. It is called as closure function. The one more is, suppose s is derives dot ab, then it means that we need to add closure function of only a. We do not need to add closure function of other one. It only means that we need to add closure function of this a. So I will write a derives dot a like that. So this is the concept of closure function. I will tell you while solving the question as well, don't worry. Now the next terminology is goto function. What is goto function? Goto function is basically, okay, don't worry, don't worry, I will tell you with the example and it will be clear to you while I will discuss the example, because until and unless we will not solve a real time example, it will not be clear to you. So it is necessary to solve this with the example. Okay, goto function. The task of the goto function is to move dot one position toward right hand side part. The task of goto function is to move dot one position toward right hand side part. Corresponding to the given grammar, total number of LR0 items is computed by closure function and goto function. And we need to convert LR0 item into DFA, and then we need to convert our DFA into LR0 parsing table. So guys, if you are not getting the theory, let's solve it so that you can get the concept clearly. Our grammar is as derives AB, A derives A, and B derives B. Okay, now the main question is we need to answer it. We need to design LR0 parsing table. So before, sure. Okay guys, don't worry, I am starting directly from the question so that it can be clear to you. After that we will get to the concept of theory. So first step is we need to make an extra augmented grammar like s dash derives s. It is step 1, and remaining production we need to write as it is. Remaining production I have write it. It is my I0 state of DFA. I am reading out comments. First, we are not able to read the entire statement only. Okay, guys, don't worry. Just focus on this slide now. After this slide, I will share the remaining slides or the slides which you have missed. Right? Just focus on this, that how to construct LR0 parsing table here. Just focus on this slide because it is difficult for us to directly understand the topic from the theory. Until and unless we will solve the real example, it will not be clear to us. Okay, so just focus here first, then I will solve all your queries. Just focus here, be patient, because I need to clear each and every concept of your regarding LR0. So our goal is we are we are doing LR0 parsing table, we are constructing LR0 parsing table. Now step 1, in step 1 we have added one extra augmented grammar in our I0 state. Step 2 is we need to make LR0 item. How to make LR0 item? By adding dot in the front of right hand side element. This is step 2. Okay guys, now after that I need to parse, I need to start parsing. So I can traverse one state with, okay, the concept here is that just the next element after dot we need to traverse all these elements. So I can traverse one element like s, and if parser has readed this element, then this state would be like s dash derives s dot, means I have to move this dot one 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 position apart after reading it out. Okay guys, so I have read s one at a time. Now I need to read a. When I will read a, I need to write it like s derives a dot b, because once I read b, compiler read b, parser read b, this dot will be moved to one position on the right hand side. Okay, and it will be like that. Now the property of closure function will be used here, because dot is existed before the non-terminal. So I need to write all the transition of b. What are the all transition of b? B derives dot b. So I need to write b derives dot b here. Why? Because closure property, closure function I need to add. So on traversing this grammar with a, I am getting this state. I can term this state as I1 and I can term this state as I2. Okay guys, initially step, I am again repeating until now. Initially we need to add this extra augmented grammar, that is s dash derive as. In next step we need to add dots on the right hand side part of the non-term, on the right hand side part of the transition, just like that. And we need to traverse. Now I have traverses this one I need to traverse it like that. So how I am traversing this a, whatever we are traversing we will write it like that. Now if I will traverse a, it would be like a derives a dot, a derives a dot, because I have traversed a completely. So this dot have moved one side on the right side. Now in next step I need to move this b. So now this b will derive to b dot. So I have traversed this one and this one. All this one has have traversed from this state, and I am creating DFA. This is my DFA construction is going on. My DFA construction is going on. I have named this one is I0, I1, I2. I can name it I3. I can name it I4. Now on I can I traverse it again? No, it is completely reduced, because when the dot is on the rightmost side, when the dot is on the rightmost side, it means that we have completely reduced it. No need to go again. So I need to reduce this. So I can reduce it one with the b, because I am having dot on the left side of b. So on the b I can reduce it like s derives a b dot. It is my next state, and I can also need to derive is b derives b dot, but b derives b dot is also here. So I can forward it like it, that on small b it would be b derives b dot. That state is already existed. That is why I didn't created another state, because it will confuse the parser. So we need to do it like that. Now this extra state is created, and this will I will name it as a b I5. Now this is completely reduced because dot is on the right hand side, and here it is completely reduced because dot is on the right hand side. So I am getting 6 states. This is my LR0 DFA. It is my LR0 DFA. LR0 DFA have 6 states. My LR0, this grammar's LR0 DFA have 6 states. One I0, second I1, I2, I3, I4, I5. How can I say that this is completed? Because all states are reduced completely, because here we are getting dot at the rightmost position, dot at rightmost position, dot at rightmost position, dot at rightmost position. So this is completely reduced now. Is it clear? Guys, DFA, are you getting how to construct LR0 DFA? Just respond me. Are you getting how to create LR0 DFA? If it is clear, then I will go to LR0 parsing table. Okay, good. Means how to create LR0 DFA is clear to you. Now I need to show you that how to create LR0 parsing table. Now our main function is how to create LR0 parsing table now. Okay. Further, if any student have any kind of doubt, they can ask, right? No problem. Okay, so it is my LR0 DFA. LR0 DFA. Now I am creating LR0 parsing table. LR0 parsing table. But my LR0 parsing table will be constructed on the basis of LR0 DFA. On the basis of this DFA, I will construct LR0 parsing table. Now आपने ये नोट किया था ना guys? You have all noted ना this states of DFA, action and go to. So in parsing table, initially I need to mention states I0, I1, I2, I3, I4, I5. I have 6 states from I0 to I5. So I have mentioned these 6 states here. These are the states of DFA. They are the states of LR0 DFA. Okay. Now I have two parts in my LR0 parsing table. The one part is called as action part, and the second one is called as go to part. In my action table, I need to put all terminals. What terminals I have? I need to put all terminals. A is a terminal, B is a terminal. So I need to put A and I need to put B. But in action table, I need to always put dollar. Dollar is just put it for only except state. I will put the theoretical points. Don't worry. Dollar is only added. Dollar is always be added in action table to for except state. For getting except state, we need to put dollar. So in action table, these are the entries. A, B and dollar. A, B are the part of non-terminals. So whatever terminals are there, A, B are the part of terminals. Whatever terminals are there, we need to put it. A is terminal, B is terminal. So I have put it in the action table. And dollar is always be part of action table. Okay, guys. Now in go to table, I need to put states. I need to put non-terminals. What are non-terminals? S is a non-terminal, A is a non-terminal, and B is a non-terminal. So in my go to states, I will put S, A, and B. So is it clear, guys? यहाँ तक आपको आ रहा है समझ में? Is it clear till now that what we are doing? Please show your response in comment box. Is it clear? Okay. So in our LR parsing table, we have two parts. One is action part, which will contains action part will contain terminals. Go to part will contain non-terminals. Okay, guys. Now this is our empty LR0 parsing table. Now I need to fill this parsing table. How will I fill this parsing table? Just focus here. Just focus here. I0. I need to see what I0 is doing on A. What this I0 is doing on B. I0 is doing on B is reducing. I0 is reducing on B. So let's give equation. This is equation 1, this is equation 2, and this is equation 3. You can also say that this is transition 1, this is transition 2, and this is transition 3. So I1, I0, that is I0 on A. I0 on A, what it is doing? I0 on A, it is reducing. But in which state it is reducing? In which state it is reducing? In I3 it is reducing. In I3 it is reducing. Okay, no problem. So what it is reducing? A derives A is reducing. Which equation it is? It is second equation. So I will put I0 on 2 is R2, R2, R2. I will put it like that. Why I put R2, R2, R2 here? I put R2 here because my equation on I0 on A is this. A derives A. And this is my second equation. So I put is R2. Means reduced to. Second transition is reduced. So I put it R2, R2, R2. In all three, in all the space of action. In all the space of action, I have put it. Okay, sorry. In I0, okay, I3 is reducing. Now I0 is not reducing. I0 is not reducing. I0 is not. I3 is reducing. On small a, I3 is reducing now. So I have put it wrongly. R2 will be on I3. R2, R2, R2. Because I3 has reduced. I3 has reduced here. If you are getting confused, don't worry. I am discussing it from once again. I0, what I0 is doing? If I observe it from S, if I observed it from S, I0 is accepting me on I1. I0 is accepting me on I1. So I0 on I1 I am getting accepting state. So here my automata will get accepting state, but I need to write it on last. But here I have written it firstly, so don't worry. Now I0 on capital A, I0 on capital A, it is shifting. It is shifting on I2. It is shifting capital A. It is shifting on I2. I2 means 2. So I0 on A is shifting on I2. So I just need to mention the next state name. What is next state? I0. This is I0, and I0 on A is shifting here. Shifting to which state? I2. So I just need to write the name of state 2. So I will write 2 here. Okay. Further, if I will see S on S, S on S dash on S, it is shifting to 1. It is shifting to 1. It is shifting to 1. I1 means S on S, I can write it 1. Why I write 1? Because on I1 it is shifted like that. This I0 has shifted on I1 like that. I0 on A. I0 on A. Small a, I0 on small a, it is shifting on I3. So I need to write it S3 here. Why I need to write S3 here? Because I0 on A is shifted to my third automata. See here, I0 state is this, and this small a is shifting on I3. As it is shifting on I3, so I need to write shift. So and on B, I0 on B is shifting to I4. I0 is shifting to I4. So I0, I1, I2, I3, I4. So on small b, I0 is shifted on small b. On small b, I0 is shifted to I4. So I will write S4 here. I will write S4 here. Why? Because I0 on small b, has shifted to I4. So now I have cleared all the transition of I0. Now move to I1. I1 is reducing, I1 is reducing, but I1 contains starting state. So whenever starting state is accepted, you just need to make accepting state in the place of dollar. Okay, I will give you break guys. Just after completion of this I will give you break. Just completion of this parsing table I will give you break, don't worry. I Do you need break guys? 5 minute break. After that we can discuss construction of LR0 parsing table. You can. Okay. You can take 5 minute break. No worry. You can take 5 minute break, and after that we will discuss construction of LR0 parsing table. Don't worry. Take 5 minute break. Don't worry. Take 5 minute break and then we will discuss. I will resume session on 6:21. I will resume session on 6:21
सर
p.m.
ब्रेक दे दिया सर.
Yes, sir. 5 p.m. 5 minutes. Yes, I will discuss. Shall we start, guys?
Hi, sir. Shall we start, sir?
Yes, sir, we can start.
Okay, sir. You can start, sir.
Okay. So, guys, candidates, are you ready? Can we proceed with the current question with the process of construction of LR0 parsing table? Please respond in the chat box. Don't worry, after this discussion you will get the complete concept of parsing table and you can solve it anywhere, right? Don't worry. Okay, so I am starting the concept construction of LR0 parsing table. So once again I am telling you that how to construct DFA. Still you can get it. I will do it fastly because all of you know the how to construct DFA, right? What is the first step? What is the first step? First step is create augmented grammar. I have created augmented grammar. In my existed grammar is S derives AB, A derives A, B derives B. I need to make it LR0 items. LR0 item means I need to add dot in the front position of the right hand side elements. So it is my I0 state. It is my I0 state. In my when I will traverse this equation 1 S derives to S with S, I will get the state S derives S dot, because whenever I will traverse with any element I need to put dot one side apart, one side I need to move this dot, I need to increment this dot on the right hand side part. Okay, this is my I1 state. In my when I will move with the A, my next state would be look like A dot B. Using closure function property, S dot B dot is existed before B. What I need to do, I need to add all the transition of B, and I only have one transition of B, that is B derives dot B. So this state would be there. This would be considered as I2. If I will traverse it with the small a, it would be look like A derives A dot. It I can name it I3. And if I will traverse with B, my next state would be B derives B dot. It would be I4. Now this is completely reduced. I1 is completely reduced. I3 is completely reduced. I4 is completely reduced. But I2 is not completely reduced. So I further need to reduce it B with B, because on the right hand side of this dot B is existed. So my next step would be look like S derives AB dot. Now I can name it I5. As I4 is there, I5. Now this I5 is also completely reduced because dot is existed on the right hand side. And I need to make one more transition with small b, because dot is on the left side of B. So this will be reduced on I4, because B derives dot B will be reduced like B derives B dot. So this is the DFA. This is LR0 DFA of my following grammar. Okay, you don't have any problem until that. Now there is a need of construction of LR0 parsing table. There is a great need of construction of LR0 parsing table in order to find whether the grammar is LR0 or not. So LR0 parsing table, for LR0 parsing table, what is the prerequisite? We need to mention the number of states here. Our table consists of following. It contains action part, it contains go to part, in action part, what we have to mention? We have to mention all terminals. What are terminals? A and B are terminals, so all terminals will be on the action part. A would be here, B would be here, but as I told you, we always need to make dollar here. We always need to add dollar in the action table. In go to table we need to add non-terminals. What are non-terminals? S is non-terminal, A is non-terminal, and B is non-terminal. So S should be added here, A should be added here, and B should be here added here. Okay, now how many state do I have? I have 6 states from I0 to I5. So I need to mention it here like that: I0, I1, I2, I3, I4, and I5. Okay guys, this is the DFA stats of DFA. Now one important thing is that in my action table, just a second. In my action table, I need to perform shift and reduce operation in action table. I need to perform shift and reduce operation in my action table. And in go to table, I just need to mention the name of next stats, means the stats in which it is going to. Okay, so if I started with I0 means this state, I can mention it as equation 1, equation 2, equation 3. So this I0 on S, the next state on S is I1. On next state on S is here, I0 is here. On respect of I0, I have S here, but I0 on S, the next here I need to mention the name of next state. What is the next state? 1. Why 1? Because I0 on S is going to I1, so I need to mention the name of this state as a 1. Now I0 on capital A, the next state is I2. Means I need to mention the name of state as a 2 here. I0 on B, capital B. I0 on capital B. Can I am traversing I0 with capital B? No, I am not traversing any statement from capital B, because I am only traversing capital S, capital A, small b. There isn't any capital B directly traversing from I0. We are traversing B from I2, but we are not traversing from I0. So I am only lefting B as a left. I am not writing here anything. It is left, blank. Now I0 on A, I0 on small a, it is shifting to I3. My A is shifting to I3 from I0. So I0 to A, I am shifting to third state. So I will write S3, because I need to mention shift and reduce instruction in action table, and I need to mention next state in go to table. In go to table, I only need to mention next states. In action table, I only need to mention shift and reduce action. Okay guys. Now I0 on B. If you will see here, I0 on B, I am shifting this B to I4. Means I am shifting B to S4. Shifting B. S stands for shift. 4 stands for in fourth state. S stands for shifting I0 on third state. Okay. Now I1 is basically the final state, starting state. So basically start for I1 in all table, it will be put at on the place of dollar. It will be like except. I will write only A, because my action table consists shift, reduce, action, or error, as you jotted down in this chart na. My action table consists shift, reduce, action, or error. And in go to table, I only need to mention in next state name. I do not need to mention anything else. I only need to mention next state here. And in action table, I can mention shift, reduce, accept, or error, whatever is there, right? So following these rules, what I am doing? I am doing accepting here. Why I write I1 on $A? Because I1 is accepting starting state. Whenever this is augmented production, this is called as augmented production. Whenever augmented production is accepted, we write it on the dollar. We write it on the dollar. Now we are not moving I1 anything else on other step. Now come to the I2. Come to the I2. On I2, can we moving small a? We are not moving small a. Can we moving small b? Yes. From I2 we are moving small b to I4. From I2 we are moving small b to I4. So what I will write? I2 on small b, I will write here S4, because I am shifting this small b to I4 here from I2. So I write here S4, shifting the terminal B from I2 to fourth state, because I need to mention shift and reduce action in my I2 in my action table. Now from I2, can I am moving A? No, there isn't any transition of A. Can I am moving B? Yes. What I am doing with B? I am moving to the next state. What is next state? I5. I5 is the next state. From where? I2. So from I2 to B, I I am moving to I5. So I will only write 5 here, and I will leave it blank. Okay guys, I will leave S and A blank on I2. Why? Because from I2 there is not any transaction of S, there is not any transaction of A, there is only one transition of B. So I just mentioned 5 on B. What it means? It means that I2's next state on B is I5. This 5. And why I only write B 5? Because according to the rule of go to table, I only need to mention next state name here. Now let's come to the I3. Focus here. I3. What I3 is doing? I3 is reducing. I3 completely reduced. It is not moving any state, etc. Right? It is reducing. It is reduced. I3 is reduced. So it reduced? It reduced A derives A. It reduced A derives A. As per the sequence of our grammar, it is 2. So I am writing A derives A as a R2, reducing second instruction. Where? On I3. So I3 is reducing R2, R2, R2. So on all the entries of action table, I need to reduce R2 on A, B and dollar. I need to put R2, R2, R2. In action table only. In go to table, I do not need to do anything. I only need to reduce and shift in only action table. Now let's come to the I4 state. What I4 is doing? In I4, this transition is reducing. Which transition? B derives, B is reducing. It is reduced. Which equation it is? It is third equation. So I will name it as a R3. So I4 is reducing R3, R3, R3. Now come to the I5. I5, what it is doing? It is reducing. It is again reduced. How I can say it is reduced? Because on the rightmost position I am finding dot. It shows me that it is reduced. H derives AB. Which equation it is? It is 1. So I will say R1. So I5 is reducing R1, R1, R1. It is the LR0 parsing table of this grammar. Is it clear to you guys? Is it clear? Comment me. Is it clear that how to generate LR0 parsing table of any grammar? If you have any doubt, ask. I will solve your all kind of doubts. Good. Means you are getting that how to construct LR0 parsing table. Okay. If any student still have any doubt that sir how to create, why you put R2, 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 R1, it is rules that I need to perform shift, reduce, accept an error in action table. I need to put next state into my go to table. Okay. ओके, बनी इज आस्किंग एक्शन टेबल का I1 I2 एंड I0 नहीं समझा. ओके, I0 I1 एंड I2. सो गाइज इन एक्शन टेबल I0 I1 एंड I2 में क्या हो रहा है, I0 ऑन स्मॉल a, if you will observe here, I0 on small a is shifting to I3. If we are shifting, we are only shifting to a particular state, that is I3. So I only mention S3 here because I am only mentioning I not, I am shifting this a, I am shifting this a on third state. So I write that S3 is the state, means from I naught this a is shifting to third state. From this I naught this b is shifting to fourth state. Here you need to leave it blank. On I1, on I1, on I1 you are not doing anything with a and b, so I just leave it blank because from I1 I didn't play with a and b, so I leave it blank. उसके बाद from I2 I didn't have any transition of a. From I2 I didn't have any transition of small a, that is why I leave it blank here. From I2 I only have transition of b. What transition of b? From I2 I have transition of small b. From I4 it is shifting this b to this fourth state, so I have jotted down S4 here and I am leaving dollar as a blank here. In shifting part we do not need to do anything with the other space, but when we reduce in LR0 parsing, when we reduce in LR0 parsing, we need to reduce in all action table entries. There is a rule that when we reduce, we need to reduce in all the entries of action table, but we do not need to shift in all entries, right? We only need to reduce it. In all the entries of action table. It is the rule of LR0 parsing table, which is mentioned in the theory, which we haven't discussed because I want to discuss you example first. So is it clear guys that how to construct LR0 parsing table? Is it clear? If anybody still have doubt, just ask me. I will solve each and every doubt of yours. Don't worry. Good, clear. Okay, someone is asking R3 and R1 again. Shonak, R3 and R1. If you will observe I4 here, in I4 I am reducing B derives B. B derives B is third equation. That is I am reducing third transition. Where I am reducing? I am reducing third transition on I4. So on I4 I reduce R3, R3, R3. Why I mentioned R3, R3, R3 in all steps? Because in it is the rule of LR0 parsing table that I need to mention reduce action in all the entries of action table. Similarly on I5, I have reduced equation number 1. So I mentioned R1, R1, R1 on all the entries of action table. Okay guys. Now in this table, I am not finding any single block where reduce conflict or shift reduce conflict occurring, because every block is unique. Even though in any single block I am not finding that whether shift can also take place or reduce also can take, means reduce conflict is also not accepting is not occurring, and shift reduce action is all shift reduce conflict is also not occurring. So we can conclude this grammar is LR0 grammar. This grammar is LR0 grammar. I can conclude that this grammar is LR0 grammar. Why? Because no shift reduce or reduce conflict occurring in this table. Is it clear guys? What I have taught to you regarding LR0 parsing table, is it clear? Yash is asking last 3 entries. Okay, last 3 entries. R1, I3, okay. Yash is asking about last 3 entries. So just focus on I3. On state I3, what I am having, I am reducing this A. How can I say it is reducing? Because this dot is on the rightmost side. So I can say it is reduced. Which equation it is? It is R2 equation. Second equation. So I am reducing I R2 on all the entries of action table. R2, R2, R2. These three entries A, B and dollar is the entries under action table, and in that I am reducing I3. This is the rule that if we are reducing in LR0 parsing table, we need to mention reduce actions on all the entries of action table. You will get that theoretical points in the notes, right? Similarly, I4 is also getting reducing. I4 on I4 I am reducing R3. So on I4 I have reducing R3, R3, R3 in all the entries of action table. Similarly, I have reduced R1, R1, that is first transition on I5. So I5, R1, R1, R1. So this is, so as in each block I am not getting any shift reduce conflict or reduce conflict. So I can say this is my LR0 grammar. This is my LR0 grammar. Is it clear, guys? Good. Okay, everybody is answering yes, clear to you, right? Next question is for you guys. Okay, when you will say grammar is LR0 grammar detection, if any grammar LR0 parsing table contains either shift reduce conflict or reduce conflict, that is not LR0 grammar. Otherwise grammar is LR0. Means in any LR0 parsing table like that, if you are getting reduce conflict or if you are getting shift reduce conflict, then you can say it is not LR0. But if you are not getting reduce or shift reduce, then it is LR0. Is it clear? LR0 grammar detection. Next question is in front of you. Construct a LR0 parsing table for the following grammar and verify given grammar is LR0 grammar or not. Very, very important question. It is previous year GATE question. Solve it, guys, and answer me whether this grammar is LR0 grammar or not. Answer me. If you all are answering me, then I will understand that LR0 parsing table is clear to you. I need answer. Just solve it. I am giving 3 to 4 minutes so that you can generate DFA first, and after that you can construct parsing table. Do it as early as possible. It will not take more than 4 minutes. Generate DFA in 1 minute, 2 minutes, and then generate parsing table from DFA in next 2 minutes. It is the strategy to solve the question. Not more than 4 minutes you need to take, right? Just solve it. If you find any doubts in any step, in any transition, just comment in the chat box. I will try to solve it, but at least solve the question. Try the question because it is previous year GATE question, and if you are able to solve it, means LR0 parsing table is clear to you. I am expecting from every student to answer the question. Are you solving, guys? Are you solving the problem? Good. Keep solving. Verify that this grammar is LR0 grammar or not. Very good. Soumya has answered correctly. The very earliest answer that I got from Soumya, it is LR0 grammar, and the answer is very correct. Very good. You got +2 marks in GATE exam. Good, Nikhil. Very good. Solve it. I will also tell you the solution. Don't worry. If some candidates are unable to solve the question, don't worry. I will tell you the detailed solution. But I am expecting. Okay, Sabrina has also answered the correct answer. Piyush, correct answer. Bunny, don't worry. Just keep solving. I will try. I will solve in front of you. Don't worry. Saksham, good answer. Correct. Very good. So, Soumya has answered it correctly. Nikhil, Sabrina, Piyush, Saksham, Manjit, Anjali. Very good, guys. Okay. So, if some candidates are unable to solve the question, just focus on the screen. Now I am solving. What is the first step, guys? Add augmented grammar. Add augmented grammar like that. Add augmented grammar like that. This is my I0 state. What is the second step? Make them LR0 item. This is LR0 items. This is the second step. What is third step? Do transition. I need to do transition from initial step S. The next step would be like S dash derives S dot. It is reduced in I1. Next one is from open brace. From open brace, the transition would be like S derives open brace. This dot will move to one place on the right hand side. It would be like that. According to the rule of closure function, I need to add all the transition of S here. What are all the transition of S? S derives dot S and S derives dot A. It is the rule of closure function, and because of the rule of closure function, I have added this one and this one transition again. Why? Because if I am finding this dot on the left hand side of any non-terminal, I need to write all the transition. That is why I have added this two transition again. I am again traversing on small a. On small a, I am shifting it like that. If it is I2, then it is I3. Means I have reduced a on I3 and shifted a from I0 to I3. So it is completely reduced, but this is not completely reduced. So on S, it will be more like S derives open brace S dot this S. On S, it will be more like that, isn't it? It is my state 4. And on small brace, if you will observe, S derives, it will repeat itself on capital S, isn't it, guys? On the transition of open brace, it will derive itself. So I have make a loop on the open brace. On the open brace, I can do it like that. The transition of open braces is like that. I am explaining I2, guys. Partially I am explaining I2. In I2, one transition on S. So on S, I have jotted it like that. Open brace S. This dot is moved to one right hand side, one position on the right hand side like that. On small brace, the same state I am getting again. That is I2 I am getting again. So I made loop. And on small a, I am getting I3. So on small a, I am traversing to I3. Now only this state need to traverse. On close brace, it would be like S derives open brace S and close brace and dot. It is again reduced in I5. So guys, total states are from I0, I1, I2, I3, I4 and I5. Total 6 states are there from I0 to I5. Is it clear to all, guys? Is it clear, guys? To all the candidates, please comment me. Is it clear to all the candidates? Is it clear to all the candidates? Good. Now, if you are able to generate this DFA, then you need to generate LR0 parsing table. In LR0 parsing table, number of DFA states I0, I1, I2, I3, I4, I5. Here it would be action table. Here it would be go to table. In action table, what I need to do? In action table, I need to mention all the non-terminals. What are non-terminals? Open brace, small a, close brace. As I said, dollar is always with the part of action table. In go to table, I need to mention non-terminal. Only one non-terminal is there, which is only S. It is only the non-terminal. So this is the structure of parsing table for this grammar. Okay, now I am filling this parsing table, guys. I note on small braces. I note on small brace, it is shifting to I2. So I can write shifting on second state. I note on small a. It is shifting to I3. So I will write shifting on third. I note on small open close brace, nothing is there. Leave it empty. Nothing is there. And I note on capital S. It is shifting to 1. So in go to table, we only need to mention the name of a state. So one would be there. Now I1 is accepted as it is a starting state. So you can just mention A on the place of dollar and leave the blank on other spaces. Now focus on I2 on small brace. What it is doing, it is shifting on itself. Means shifting on second state. So I2 on small brace, it is shifting to itself, that is S2. I2 on small a, it is shifting to 3. So I2 on small a shifting to 3. Now I2 on capital S shifting to 4. So I2 on capital S is a part of go to, shifting on 4. I just need to mention name of state and leave other two as a blank, because there is no transition of close brace and dollar from I2. Okay. Now focus on I3. I3 is reducing. So suppose this is equation 1, this is equation 2. So I am reducing H derives A dot, means I am reducing R2. On I3 I am reducing R2. So on the all entries of action table, R2 would be taken place, isn't it? Why? Because on I3 I am reducing H derives A dot, and in action table, according to the rule of action table, I need to place reduce action on all the entries of action table. So R2 and leave go to table blank. Now focus on I4. What it is doing, it is only performing one transition for close brace. It is doing shifting. It is shifting on I5 on close brace. I4 is shifting to 5. So mention I5 S5 here, shifting on 5. I4 on close brace is shifting. To fifth state. Leave all other state as blank. And I5 is reducing the equation number 1, that is S derives S under close braces. It is completely reduced. It is equation number 1. So I can write is a reduce 1, where I need to write reduce 1 on all the entries of action table R1 and leave go to table blank. Now if you will observe here, in any block we don't have any shift reduce conflict, and we also don't have any reduce conflict. As we don't have any shift reduce conflict and reduce conflict, that is why this grammar is LR0 grammar. Is it clear to you guys? This was the previous year GATE question. Is it clear to all the candidates? Please comment. Good. Clear to all the candidates. Very good. Now I am just requesting that can we take extra 10 minutes, guys? 10 to 15 minutes extra, so that we can complete our today's module. Just need 10 to 15 minutes extra. Okay. Now these were some of the examples under LR0 parsing table. Now I am discussing theory to you so that you can now understand it better. Okay, I hope you got all the steps of construction of parsing table. These were the 5 steps, and before that, this is the theoretical point of LR parsing algorithm. That if action table entry SA is accept, then input is valid and parsing is successful, like in our example. Anjali, I will also tell you shortcut. Don't worry, but the complete procedure is necessary here because many questions are there in which we can't apply. In gate questions, we can't apply shortcuts. In other exams, we can apply shortcuts. So there is some shortcuts which I will discuss in our upcoming session. So don't worry, I will not leave any shortcuts with you. I will discuss all shortcuts of compiler design with you, right? Don't worry. Okay, Shonak, sir, how to understand if there is a conflict? Yeah, I have prepared that session for you also. Don't worry. I have also prepared one session that how to understand conflict. Yes, don't worry. Just after these 2 slides, I will discuss this kind of questions. Okay. If action table entry SA is blank, then there is a syntax error in the input and parser written into the if our accept state is not is empty, means parsing is having error. Basically, if we are parsing any string successfully, then our string will get accepted. Option 3, statement 3, if the action table entry is on A is shift J, then shift A into the stack and then push J into top of the stack and increment look ahead symbol. Means what we had done in this na, that once we need to push it into the stack and then move this dot to one extra place. This is they are explaining with the example of theory, but I think there is no need of discussion of such kind of theory because you understand all the concepts clearly, that whenever we are shifting the element, suppose we are shifting A, means it is moving to the stack. It is itself clear as a computer science student, it is itself clear that this A is shifting into the stack and we are moving this dot to the next place, right? Now if we are reducing this, it itself means that we are popping off it and we are replacing it with somewhat handle. So this is SR parser, right guys? Just one more question guys, because this question will clear conflict concept of you. This is very important. Solve it. Verify the following grammar is LR0 grammar or not, because this is very important concept and it will clear all the concepts of here. Just solve it, that whether this grammar is LR0 grammar or not. Solve it. This is ISRO's question. Verify the following grammar is LR0 grammar or not. Yes, please show the grammar slide of previous question. Grammar slide of previous question. Yes, are you asking about this? Which grammar you are asking about? Yes. Okay, after this we will only discuss one more question and I will end today's session of LR0 parsing, and I will give you some assignment questions as well, because this is very important questions in order to understand the next level of parsing like SLR1, LLR1, CLR1, right? Yes. Okay, yes, I will share which grammar you are talking about. Question 6th, question 5th grammar is this. Are you talking about this grammar guys? Yes, because other students are solving the question, that is why I am holding this slide. Sir, get. Okay. This is the one. This is the first question of GATE. Question number 6. Yes, it was question number 6. The grammar is s derives open brace s and close brace and s derives a. It was the question. Okay, you can note that grammar, don't worry. And this is the question number 7, which I had given to you. Tell me whether this grammar is LR0 grammar or not. After that, I will only discuss one more question and will end today's session, because this question discussion is very important, and you need to solve it and be interactive, because your interaction is helpful for yourself. As much as you will practice here, as much as you will interact here, your confidence will level up and it will help you in the real time GATE exam. This is LR0 grammar or not, guys? Answer me. This grammar is LR0 or not? It is not a grammar. Prasanna has answered not a grammar. Why it is not a grammar? Close the door. Prasanna has answered not LR0, not LR0. Yes, it is LR0. Many candidates are answering that it is LR0 and many candidates are answering that it is not LR0. Why? It is very simple, guys. It is very simple. You just need to add one more augmented grammar. E dash derives E. Then E derives T plus E. E derives T and T derives I. Add, make them LR0 items like that. These are LR0 items. This is our I0 state. Okay. One move is from E. So it would be like E dash derives E and it is reduced. It is in I1. From T, we can say E derives T dot plus E. Okay, guys. But if you will say on T, I have did this na T dot. Okay, on, okay, sorry guys, it is T plus E or E plus T. T plus E. T dot plus E. And on T, one more transition is there. E derives T dot. E derives T dot. If you are somewhat smart able na, you can itself say, sir, from this step we can shift plus, but we can reduce this T, means you will get shift reduce conflict here. Can we say that, guys? Just comment me. Can we say that by solving just like that, just from here, can we say that it is shift reduce conflict? Just comment. Is it a shortcut to solve that? Here itself we are getting that here this T is reducing, but we can again shift. So parcel will get confused that whether I should reduce this state or whether I should go with the shift one. So shift reduce conflict will exist here. So you can stop here and directly conclude that shift reduce conflict will be existed. No need to construct parsing table. No need to construct parsing table. Here itself you can conclude that, sir, this T is reduced here and we can again shift that addition operator. So this is shift reduce parser. Shift reduce conflict is existing. That is why it is not a LR0 grammar. It is not a LR0 grammar. Is it clear, guys? Is it clear to all of you? Or anyone is having any kind of doubt? Because if it is clear, then it is very, very good for you. Means you are getting the concepts of LR0 parsing. Yes, 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 yes. Okay. All the candidates has answered yes, right? So next question I am giving to you. Okay. Next question is this. Verify the following grammar is LR0 grammar or not. You can directly solve. No need to construct parsing table. Hello. 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 Poshali has asked me to repeat. Okay, Poshali. Poshali has asked me to repeat. Poshali, I am repeating the previous question. Here on my transition T, see here. This was my grammar. This was my grammar, Poshali. And I added an extra augmented grammar like that. I added grammar like that T plus E. E derives T and T derives I. Okay. I added them as a LR0 item and I mentioned it as a I0 state. On E state, what I had do, I just traversed it and I made it like E dash derives E dot. So it is reduced on I1. It is reduced on I1. When I traversed on T, when I make a transition on T, what I am doing, I am traversing it like I am making this dot one step forward on the right hand side. It is like T dot plus E. But one more transition of T is existed. So what I did, Poshali, E derives T dot. Now in that condition, you yourself can say from the points which I have discussed that on the right hand side I am getting points. On the right hand side I am getting the point, means I can further shift this. I can further shift this. But here it is reduced. Means if I name it as a I2, means I2 is reduced here. E derives T dot. But I can also shift it one more place in next state. So you yourself can say that, sir, here shift reduce conflict will occur. That is why it is not a part of LR0 grammar. Okay, Poshali, is it clear now? The next question has answered by many candidates. Soumya has answered it correctly. Sabrina has answered correctly. Saksham is also answered correctly. Rana answered correctly. Shonak has answered correctly. Soumya has answered correctly. Anjali, Prasanna, Sabrina, Poshali. Okay. Most of the candidates has answered it correctly. So guys, the process is again same. Add augmented grammar. As derives AA. Okay, as derives dot AA. A derives dot AA. A derives A. This is my I0 step. On S derives S dot. This is my I1 step. On A, S derives A dot A. As this dot is existed before this non-terminal, so I also need to add all the transition of A here. I also need to add all the transition of A here. So I will write A dot AA and A derives dot A. Here I am following closure property. It means I am following closure property. Okay. Now small a, on small a, what I can do? Small a derives A dot A and A derives A dot. Here itself you can say that in next step I can shift to capital A, that is non-terminal A, but it is reducing itself. Means suppose I2 is there. In I3 state, I am again getting shift and reduce conflict. Clear, guys? So it is not a LR0 grammar. It is not a LR0 grammar. Clear to all the candidates the solution of this question? Is it clear, guys? It is one kind of shortcut. You do not need to make parsing table. Here itself in the DFA you can answer that whether the grammar is LR0 or not. Good. Very good. I am getting a very positive response from you guys, and it makes me really happy that you are solving the questions and attempting all the questions which I have discussed with you, right? Now one more question and then I will give you assignment question, right? Just last question for the day. Just last question for you guys. Verify the following grammar is LR0 grammar or not. Just last question of the LR0 parsing. And we will conclude the LR0 parsing today, and we'll discuss SLR1, CLR1 and SLR1 parsing tomorrow. It is Saksham has answered it, not LR0. Okay. Very good, Saksham. Very good. Reduce conflict. Good. Yash has answered it is. Yash, please verify your DFA. Yes, please verify your DFA that why you are getting it as a LR0, because other candidates are getting is a not LR0. Not. Manjit has answered again correctly. Good. Saksham answered it correctly. Yes, please verify. Not. No, it is a conflict. Okay, okay. It is a conflict. Correct. Sabrina has answered correctly. Soumya has answered it correctly. Poshali, very good. Anjali has answered correctly. Sabrina has also mentioned the reason. RR conflict. Good, Rana. Sabrina is good. Okay. So let us discuss. You need to mention augmented grammar. S derives S with the LR0 item properties. Again, S derives dot A derives, S derives A derives small a. It is our I0 state. It is our I0 state, and from this state, if I will go through starting symbol, if I will traverse with the starting symbol, I will be like S dash derives S dot. It is my I1 state of the DFA. On capital A, I can traverse it like S derives A dot. It is completely reduced on I2. On small a, I am getting S derives A dot, as well as I am getting A derives A dot, because two transition on A is there. So I am getting reduced with that and reduced with that. So parser will get confused. Parser will get confused that whether this grammar, whether should I reduce this one or this one. So reduce conflict is there. Reduce conflict is there. Right, guys? So it is not a LR0 grammar. It is not a LR0 grammar again, because reduce conflict is there. So I have discussed all the questions of LR0 parsing, which is existed as a LR0. If some questions have a shift reduce conflict and reduce conflict. So I think that you are now aware with all kind of LR0 parsing questions, right? Now some questions I am giving you as an assignment. Please note it and answer me tomorrow. I will ask this questions answer tomorrow. Question number 10. Verify the following grammar is LR0 grammar or not. It is an assignment question for you guys. You can note it so that I can move to the next slide, because one to more questions I am giving to you as assignment question. Have you jotted down, guys? Have you jotted down question number 10? Okay, the next question is question number 11. You also need to answer this, that verify this following grammar is also LR0 grammar or not. Very important question. Note it, because you need to solve it on as a homework, as an assignment. After solving this, you can pace up with your skills of parsing table. You can also pace up the skills of making DFA, and you can solve the questions very easily. This all are asked questions either in the GATE, ISRO, BARC, NET, IBPSSO, not IBPSSO but UGC NET, like that thing, right? So it is very important question for the GATE exam, that finding whether the given grammar is LR0 grammar or not. Good. Okay. This is one more assignment question for you guys. This is epsilon. This means that S derives epsilon. Okay, epsilon means fine, nothing, empty. So verify following grammar is LR0 grammar or not. You also need to solve this. Take this question please. Question number 12 as assignment question. Actually, in question number 11, some candidates are saying okay. Actually, in previous question, our grammar was like e derives t dot e, t plus e. In this question, we have e plus t, right? So it is somewhat different, and it makes your grammar completely changed. So you can try that. Question number 12 is that. Okay, noted, guys. Good. One more question is here. Question number 13. Verify the following grammar is LR0 grammar or not. Verify the following grammar is LR0 grammar or not. If you have jotted down, then comment so that I can move to the next slide. And we can finish LR0 parsing, means we can conclude LR0 parsing as of today, so that we can tomorrow discuss SLR1, CLR1 and LLR1. Okay, we will discuss all this parsing table because it is very important topic of bottom up parsing techniques, and 1 to 2 marks question 100% sure from one of these 4 techniques, right? So it is very important topic of compiler design. Good. Now I am concluding today's session that what is the drawback of LR0 parser. Basically, in LR0 parsing table, reduce actions are placing without considering look ahead symbols. Hence, parsing tables may contain unnecessary reduce action. As you also noted that in our parsing table of LR0 parsing table, this R2 is reducing at a particular place, either in the open brace, either in the A, or either in the close brace. But what we are doing, we are making reduce action, we are making the entry of reduce action on all the entries of action table. This is the drawback. Why it is a drawback? Because it is making our table somewhat lengthier. It is one of the drawback. So what to do to remove this drawback? Hence, to avoid this drawback, SLR1 parsing table is used. So we will discuss SLR1 parsing table tomorrow. We will also discuss CLR1 and LLR1, so that you can get aware with all the parsing techniques and assure 4 marks till now in GATE exam when we will complete LLR1, right? Till now you can say that at least 2 marks you have secured. But I am guaranteed you that after attending complete compiler sessions and taking these notes, you will completely get 100% marks directly from these notes and this question. So do attend the upcoming sessions as well, because this will help you a lot in order to get the better marks. Because from previous 4 to 5 years, all the questions that GATE is asking, directly asking from the notes, by just making somewhat changes in concept. Means if you read out and solve this kind of questions which I am sharing with my notes, you will feel 100% easierness while solving compiler design. And I am giving one more advice, that while attempting GATE exam, attempt CD first. It will increase your confidence, because if you are assuring 8 marks in first 15 minutes of your GATE exam, what is better than that? And it is the real condition, guys. Many students share this kind of experience with me, right? So I will share such kind of experience with you in upcoming sessions as well. But as of today, this kind of questions I have discussed with you, and we have concluded LR0 parsing. Okay, guys. So if anybody have any kind of doubts or queries, please ask me. I am ready to solve all your doubts and queries of now, right? So you can ask me if you have any kind of doubts or queries from today's session. If you have any kind of doubts or queries, please ask. I will try to solve. No doubts? Any kind of doubt, silly doubt, sir, इस problem में ये समझ में नहीं आया, I don't get that concept. I am ready. Question number 4. Manjit is asking question number 4. Okay. Manjit is asking question number 4. This is question number 4. How many shift action and reduce action taken by shift reduce parser? Okay, guys. This is question which is asked by Manjit. So Manjit, simply you make the parse tree, count the handle. The number of handles are, you can say that it is the reduce, and the number of characters 1 2 3 4 5 6 7, basically it is shortcut. Anjali, you are asking about shortcuts now. One more shortcuts. The number of characters in a string, number of characters in a string is called as shift actions. Total 7 characters are there, 7 shift actions. And while solving this, we got 5 handles. So 5 reduce actions. So total number of handles are called as reduce action. A total number of input characters are called as shift actions. Is it clear, Manjeet? Okay, next doubt is of Shonak. Shonak is not getting the drawback of LR0. Shonak is not getting the, just 2 seconds guys, just 2 seconds.
सर
Yes sir.
सर टाइम हो गया सर 7:20 हो गया 7:30 हो रहा ऑलमोस्ट
Sir, just two minutes sir. So drawback of
7
LR0 is
7:20 मैं
yes, sir?
मैसेज लगा उसको कुछ रिप्लाई भी नहीं दे रहे आप
Yes sir.
मैसेज लगा एंड करने के लिए 7 o'clock मैसेज करा
Okay sir.
कुछ रिप्लाई भी कुछ नहीं दिया आप
Okay sir. Actually I didn't get that sir. Actually I was busy in that sir.
okay कंटिन्यू सर
Okay. So guys,